this last stuff here real quick. Okay, so, and this is sort of, in a sense, preparing you for logarithms is what this is. These are exponential equations. Okay, so an exponential equation, you always have your unknown in the exponent. Okay, you can see that in all the problems. The x is in the exponent. These problems are designed a certain way. So what you're going to try to do on these problems is get the base the same. I'll just give you an example. Like on this first problem, we're going to have 5 to some power equals 5 to some power. And that's what you're going to try to do on all these problems. If you look at example 2, there's a 4 and there's a 2. So these problems are designed so the bases could be made the same. So again, the goal is to try to get the bases equal. And then if they are, then the exponents have to be equal. Okay, so the idea is real simple. If the bases are the same, then so are the exponents. They have to be. Okay, that's what you want to make sense of. All right, so what we're going to do on this first one is just bring down the left side. We'll just bring that down. Not going to do anything with that. But, like I said, by design, I designed these problems this way. So what power of 5 is 125? That's the third power, right? So what you can do is you can change that to 5 to the third, like that, and then you still have that raised to the x minus 1 power like that. So your goal is trying to get those bases the same. And then the other thing is, you got to remember a basic property of exponents. Like if you add x to the third to the fifth, what do you do to the exponents? Add or multiply? You multiply, right? Okay. So the thing is, that's what you're going to do with these exponents, the 3 and x minus 1, you're going to multiply those. So I'm going to just bring down the left side. So I've got 5 to the 2x plus 1. Then I've got 5 to the 3 times x minus 1 like that. Okay? Because you're multiplying exponents in that case. Now what happens is, and you'll see this on every problem I'm going to do here, if the bases are the same, then what's the deal with the exponents? They're the same also. They have to be. It's the only thing that makes any sense. So what you'll do is you'll just set the exponents equal to each other, and then you got an equation that should be pretty easy for you to solve. Okay, so that's going to be kind of the idea on all these problems, is to rearrange the bases so that they're the same. The problems are designed that way. Then for pair, it's pretty straightforward. You got 2x plus 1 equals 3x minus 3. Do a distributive property. Decide which side you want the x's on. I think I'm going to do this way. I'm going to move the 2x over there and the 3 over there. Okay, so that way I'll end up having, on the right side, I'll have 3x minus 2x. And then on the left side, I'll have 1 plus 3, okay, when I move everything then, okay? All right? So that's going to end up giving 4 is equal to x like that, okay? And that's it. Now, one thing you can do on a problem like this, too, I mean, you can check it by hand and everything, but I was going to show you maybe on a couple of these things. You know, you can take your answer and you can just plug it in. So you could go 5 raised to the 2 times 4, whoops, 2 times 4 plus 1, okay, sometimes just as easy to do that kind of in your head. So you get this, that doesn't make any sense. Well, no, it does. That's a big number, okay. So then I can do 125 raised to the 4 minus 3. So I'm just plugging it in. It's actually very easy to check all these problems on your calculator, say. Okay, it's like any other equation, you can go through until you've done that right. Okay, is everybody okay with what I did on that first example? Okay, all right. All these problems are going to have the same idea behind them. I think maybe the last one's a little bit harder to do. There's a little bit more to do on that. So the idea with this is you have a base that's equal to 2 to the x. So your goal is to write that 4 as a power of 2. So 4 is 2 to the second, so you would change that 4 to 2 to the second, and then that exponent is x to the second, okay, like that. So just change the 4 to 2 to the second, okay? And then what you got to remember on this is the exponents get multiplied. So if you see this 2 to the second to the x squared, those two exponents are being multiplied. So you would end up getting 2 raised to the 2x squared equals 2 to the x. Okay? Now, since the bases are the same, what do you know about the exponents? They are the same also, right? Okay, so the way you finish up the problem then is the exponents are just equal, so you would have 2x squared equals x, and if you can solve that equation correctly, you got it made, okay? What kind of equation is 2x squared equals x? That's quadratic, right? So what do? One side equals 0, right? And then you try to solve by factoring like we've been doing. Okay, so I'm going to move the x the other side. So that's 2x squared minus x equals 0. And that factors, you can take a common factor of x out of that. So you would have x times 2x minus 1 is 0. Okay, then you got two answers. You can do that in your head if you want to. X equals 0 would be one answer of the problem. And then the other one, you would set 2x minus 1 equals 0, solve that equation, add 1 to both sides, divide by 2. So you'd have 2x equals 1, divide both sides by 2. So in this particular case, you get two answers, okay? Because it's quadratic when you set the exponents equal each other. All right, you guys understand what I did on those first two problems? Okay, the idea is the same. And these things, again, like I said, are designed this way in this section so that the bases could be made the same. If they can't be made the same, then you have to use logarithms to solve the equation. So that's the idea, okay? All right, and again, you can always check on your calculator if you want to. Okay, so this one, notice we have a 3 and a 9. So what are you going to do with the 9? What are you going to change it to? Yeah, I know you lost an hour of sleep over the weekend. Okay, spring forward weekend. Okay, so we got 3 to the second, right? Okay, so what we have is 3 to the second, and then to the negative x power. Any suggestion about what I'd do with the 1/3? I got to do something with it. Because I want, yeah, bring it to the top, exactly, okay? So if you bring that to the top, you would have 3 to the negative 1 like that. Because your goal is to have 3 as your base on both of those, okay? All right, same idea applies. Those exponents get multiplied. So what you would have is 3 to the negative 2x equals 3 to the negative 1. Now you're ready to set your exponents equal each other. So again, the goal is always on the problem is the bases are the same. Now the exponents have to be the same. So we say negative 2x equals negative 1. And then divide by negative 2, so you would get x equals 1/2 would be the answer to that problem. Okay? All right. Now this one's probably easy enough to check. I want to just show you this without a calculator. If you go to the original problem, if we plug in x, we would have 9 to the negative 1/2 equals 1/3. Is that right? Do you understand how you could do that in your head? Okay, because what you end up having is 9 to the 1/2 is 1 over 9 to the 1/2, but a 1/2 power is a square root, so that's going to be 1/3. Okay, so you can run through the details of that and check these things out, and helps you kind of understand what you're doing on the problem anyway. Okay, all right, any question with that? Okay, all right, the next one, same idea. I see a 4 and I see a 2. So what do I need to do with the 4? Change it to what? 2 to the second, good, okay? So what I'm going to do is, I'm going to do this like this. There's, any time that you have a fraction to a power, you can realize that the 1 is to the 1 minus x power, but so is the 2. So that's a basic property of exponents. A fraction to a power just means both the top and bottom are to that power. Then we'll change the 4 to 2 to the second, okay? All right, so here's what we have. First of all, if you take 1 to anything, 1 to any power is always 1, okay? So that part is just going to be 1, so you'll have 1 over 2 to the 1 minus x equals 2 to the second, okay? Now, what should you do with the 2 to the 1 minus x, like we did on the last problem? You bring it to the top, right? Okay. When you do that, you want to be kind of careful about that, because that's going to change that negative exponent. There's more than one way to do that. One way you could do that is just write that as 2 to the negative 1 minus x in parentheses like that. All that's going to do is change it to x minus 1. Now you're ready to to solve the problem in. So we have manipulated it algebraically to make the bases the same. So therefore we just set the exponents equal to each other, and then we can solve that equation. So you'd have -1 minus x equals 2. That would be -1 plus x equals 2. And then you can just add 1 to both sides. So you get x equals 3. Okay, like that. All right? And then that's an easy one to check, and either with or without your calculator. That's the idea. Okay, any questions about what I did? Okay, so the goal on those problems was always the same. You're basically trying to get your bases the same. When you do that, you set the exponents equal and you're done. Okay, that's pretty simple. Okay, and it's really a good exercise to help you review your properties of exponents, because that's what you need when you're doing logs in. Okay, any questions about anything? Okay, all right, we good? Okay, I'm going to close this off here.